press the bell icon on the YouTube app and never miss another update.
Welcome to the third session of the chapter Sequences and Series. In the last session, we were talking about the problems from the exercise 9.2, right? So, we have solved, I think, one question from the exercise 9.8, 9.2, I think, sorry, 9.2. Now, let us continue from the second question, right? So, second question is like this. Find the sum of all natural numbers. Find the sum of all natural numbers lying between 100 and 1000 which are multiples of 5, which are multiples of 5. A simple one. Here we have to find sum of all the natural numbers between 100 and 1000, which are multiples of 5. So, let me write the multiples of between. So, here they have mentioned between, you should not include 100 and 1000. So, you write the numbers, I mean multiples of 5 in between 100 and 1000. So, now let the numbers be. So, numbers are what? The numbers, you mean multiples of 5 between 100 and 1000 are going to be like this. First number will be 105, right? Multiple of 5. Next 110, 115 and so on. And the last number will be, yes, I think 995, right? Okay. The last multiple of 5 is between 100 and 1000 is 995. Okay. So, now, you have to find sum of all the natural numbers. You mean you have to find sum, that is the Sn is equal to 105 plus 110 plus 15 and so on plus 995. You have to find this. It is very simple, students. We have A, you mean A is 105, you mean first term is 105, and D is the difference between terms is 5 we have, right. So, and also we have last term is 995, that is what L. So, by using these things, but you have to find N also, right. So, let me find N first. So, by using the last term, so L is equal to A plus N minus 1 into D, right. So, L is what? 995, that is equal to A is 105 plus N minus 1 into D. D is what? 5 into 5. So, now 995 equal to 105 plus, so 5 and minus 5. Okay. So, now 105 minus 5, that is 100. So, now this is same as 5 and equal to, so 995, so minus 100, you get, right, 995 minus 100, see this is what? 895, this is 5n. So, n gives 895 by 5. So, you get Unza 7za, so 179, right. Okay. So, you get n 179, you mean there are 179 multiples of 5. I mean there are 179 multiples of 5 we can see in between 100 and 1000, right. So, there will be 179 multiples of 5 can be seen between 100 and 1000. Now, anyway we have got n. So, Sn, you mean S 179 is equal to, or Sn is equal to n by 2 into second formula, that is what A plus L, using the first and the last term. This is 179 by 2 into A is what 105 plus L is what 995. This gives 179 by 2 into, so this is 1100, right? Okay. This gives this is 550. So 550 into 179. So 550 into 179 is you get so 9845, right? I mean 98450. You mean 98,450. So 98,450 will be the sum of all the multiples of 5 between 100 and 1000. Between 100 and 1000. This is how of finding the sum using A and L and also using N. So N is what? 179. You mean there are 179 multiples of 5 can be seen between 100 and 1000. Okay, let's move on to question number 3. In an AP, you mean arithmetic progression. In an AP, the first term is 2. The first term is 2. And the sum of first 5 terms is, and the sum of the first 5 terms, sum of the first 5 terms is 1/4 of the next 5 terms. 1/4 of the next 5 terms. Next 5 terms. Show that the 20th term. So 20th term is minus 112. See, the question is given what the first term is given, that is what A is equal to 2. Sum of first 5 terms, you mean S5 is equal to 1/4, you mean 1/4, you mean 1/4 times of sum of next 5 terms. Sum of next 5 terms. I can write sum of first 5 terms, or you can write this as the sum of first 5 terms. You mean S1 yes, A1 plus A2 plus A3 plus A4 plus A5. This is equal to 1/4 of the sum of next 5 terms. You mean A6 plus A7 plus A8 plus A9 plus A10, right? This is given. Sum of first 5 terms is 1/4 of the sum of the next 5 terms. Sum of first 5 terms I can write S5, right? Okay. And this is equal to 1 by 4 times. So sum of next 5 terms. So sum of next 5 terms I can write as S10 minus S5. S10 in the sense from A1 to A10, right? From A1 to A10, if you subtract A1 to A5, you get this A6 to A10. Hope you got this. Okay. Now, again, let me simplify this. You get 4 times of S5 is equal to S10 minus S5, or you get 5 times of S5 is equal to S10. Okay. Now, 5 times of S5. So, 5 times of S5. S5 is what? Sum of first 5 terms, that is n by 2, you mean 5 by 2 into 2a plus n minus 1 to d. Right. To a plus n, either this was 5 minus 1 into d, that is equal to S10, that is what, n by 2 into 2a plus n minus 1 to d, right. So now let me find the value of d first now. So this is for what, finding, this is, I mean, this relation I am using here, finding to d, right. A we have, a is 2, right. So we get 1 by 2 get cancelled. Here we have 5, no? So 5 get cancelled. Okay. Now you get 5 by 2 into 2a. So a is 2. So 4 plus 4d, that is equal to 2a, that is 2a is what? 4 plus 9d. Okay. Now you get what? On cross multiplication. So 20 plus 20d is equal to 8 plus 18d. So 2d is equal to, so 20d minus 18d, 2d is equal to 8 minus 20, that is minus 12. So you get d is equal to minus 6. So common difference is minus 6. Okay. So now see, we have to show that 20th term is minus 112. So 20th term, that is what, A20 is equal to a plus 19d, right, 19d. For that we need a and d. So a we have, I mean it has been given a. So d, to find d, this is the data we have given. I mean sum of first 5 terms is equal to 1/4 of the next 5 terms. Using that I have found d. This is for finding d, right. So a we have, d we have, then 20th term is a is what, 2 plus 19 into d is what, minus 6, right. So 114, right. So you get minus 101. So this is, I mean we have proved 20th term is minus 112. So this is what, third one. Let me move question number 4. Okay. Now fourth question is like this: how many terms of the AP? How many terms of the AP arithmetic progression. Minus 6, minus 11 by 2, minus 5, and so on are needed to give the sum, so minus 25. Students, here the question is, there is an AP, I mean we have arithmetic progression. AP is given by minus 6, minus 11 by 2, minus 5, and so on. There is an AP. So we get the sum of the terms of the AP is equal to minus 25 for how many number of terms? Here we don't know the number of terms. It is infinite. Actually, it is infinite. I mean, AP is what? It is an infinite sequence. And to get the sum minus 25, how many terms should be added? How many terms should be are needed to get the sum minus 25? That's the question. How many terms are required to get the sum minus 25? So here the sum is given, right? Yes. We know that formula, that Sn is equal to, here what we are finding? We are finding what n value such that the sum is minus 25. So A is given, that is what, minus 6, D common difference is minus 11 by 2 minus of minus 6, you mean A2 minus A1 gives what, minus 11 by 2 plus 6 gives, so 12 minus 11, that is 1 by 2. Okay. So D is 1 by 2. D is 1 by 2. So A we have, D we have. So you have to find n. Right. Okay, now Sn is equal to n by 2 into 2a plus n minus 1 into d, right? Okay, now Sn is given, that is minus 25. Sum of the terms is given, we don't know the number of terms. So n by 2, 2 into a, so a is minus 6, so minus 12 plus n minus 1 into d, so n minus 1 into d is 1 by 2. So let me simplify this, you get the value of n, that's it. Minus 50 is equal to 2 into this minus 50, n into, so you get what, minus 24 plus n minus 1. Okay. So now this is minus 50 into 2, so you get minus 100 is equal to, so minus 24 into minus, minus 24 minus 1 minus 25, n into n minus 25. So you get n square, n into n square minus 25n, so plus 100 equal to 0. Taken this minus 100 to right side. So 25n 100. So we have quadratic equation now. Let me solve this. You get what? 100 is there now. So yes, on so 25 is right. So n square minus 20n minus 5n plus 100 equal to 0. Now n into n minus 20, so minus 5 into n minus 20 equal to 0. This gives n minus 20 into n minus 5 equal to 0. This gives either n is equal to 5 or 20. So number of terms, when you add first 5 terms you get the sum minus 25, or when you add 20 terms again you get sum minus 25. So n is 5, or I mean if number of terms is equal to 5, n is equal to 5 in the sense sum of first 5 terms of this AP becomes equal to minus 25, and also sum of first 20 terms of this AP becomes minus 25. So this is the answer. So minus 5, 5 or 20. Okay, let me move to question number 5. In an AP, in an AP, in an AP, if pth term is 1 by q and qth term is 1 by p. Prove that the sum of first PQ terms, first P into Q, first PQ terms is sum of first PQ terms is half into PQ plus 1, where P and Q are not same. Okay, now the question is pth term is 1 by q, qth term is 1 by p. Then show that the sum of first pq terms is equal to this when p is not equal to q. Okay, now given is what? Pth term, you mean AP is given. So pth term is what? AP, that is what? A plus, right? AP, that is A plus n minus 1, n means P minus 1, P minus 1 into D, that is equal to 1 by Q. Take it as equation 1. So pth term, that is what 1 by Q given. Qth term, that is what AQ is equal to A plus Q minus 1. In place of n, we have to take Q, that's it. This is equal to 1 by P. Take it as equation 2. This is given. Then we have to show the sum of first PQ terms. You mean SPQ. Sn in the sense sum of n terms, SPQ is equal to this, half into PQ plus 1. Okay, this is data we have. Now let me subtract. You mean this is 1, this is 2. So 1 minus 2 gives, subtracting equation 2 from 1, you get A get cancelled. So here P minus 1 into D minus Q minus 1 into D. So D I am taking outside. So P minus 1 minus Q minus 1 is equal to 1 by Q minus 1 by P. So D into P, so minus 1 plus 1 get cancelled. So P minus Q equal to, here minus 1, minus of minus plus 1 get cancelled. So P minus Q remained. So here PQ LCM again P minus Q. Okay. So P minus Q get cancelled on this, on both sides. So you guess D is 1 by PQ. So to find the sum, we need two things. Here in all the questions, whatever they ask, first you have to find A and D. That's very important. Because in all the formulae, we have A as well as D as well as N. Okay. So these three things must be, we have to find first. So we have found D value. Now let me find A value. Let me substitute this D in any of these two equations. You get A. So let us take first equation. So first equation becomes A plus P minus 1 into D. D is what? 1 by PQ is equal to 1 by Q. Okay. Now, so A plus P minus 1 by PQ. So P by PQ, that is what? 1 by Q minus 1 by PQ is equal to 1 by q. So, what I am doing here, dividing p minus q by pq. P by pq, 1 by q. So, 1 by pq, here we have. So, 1 by q, 1 by q, it cancels. So, a you get again 1 by pq. So, both a and d are equal to 1 by pq. Okay. Now, let me show the sum of first pq terms is equal to this. Therefore, now sum of first pq term, that is Sn, in place of Sn we have to take Spq. I mean in here n is same as pq. Number of terms is equal to pq. We have to show sum of first pq terms, you mean number of terms is equal to pq here, I mean product of p and q equal to half of pq plus 1. So, using the formula n by 2, n is what? pq by 2, right? N by 2 into 2a plus, let me write first formula, Sn is equal to n by 2 into 2a plus n minus 1 into d. This is actually the formula to find sum of n terms of the AP sequence. Now, we have to find what? Spq is equal to pq by 2. So, 2 into a is 1 by pq. So, 2 by pq plus n is what? Pq minus 1 into d is 1 by pq. This is equal to, so pq by 2 into 2 by pq plus pq by pq, that is what? 1 minus 1 by pq. Okay. Now, this is equal to pq by 2. Let me take pq LCM. 2 plus pq minus 1. So, pq get cancelled. The 2 minus 1 is what? 1. So, you get 1 by 2 into pq plus 1. This is your required answer. So, half of pq plus 1 is the required answer. We have shown that sum of first pq terms is equal to half of pq plus 1. Simple one. So, students, in this case, I mean in AP, whatever they ask, first you have to find a, d and n. So, these are all what we do for finding a or d, that is it. A is given, no sorry, here pth term, qth term is given. So, by using those, by using these data, we have found a as well as d. After that, sum of first pq terms will be equal to half of pq plus 1. Okay. Question number 6. If the sum of a certain number of terms, if the sum of a certain number of terms, the sum of certain number of terms of the AP 25, 22, 19 and so on is 16. Sum of a certain number of terms in an AP 25, 22 to 19 and so on is 16. Find the last term. find the last term. Here AP is given by, what is AP? We have 25, 22, 19 and so on. Here we have an AP, we don't know the number of terms. The question is, sum of the numbers, some terms will be equal to 16. For how many terms? I mean, for how many terms of the sequence AP, sum becomes 16. It may be some 4 terms or some 8 terms or 19 terms, we don't know. For how many number of terms, sum of the terms becomes 16. That's what we have to find n. For what value of n, sum of the terms become equal to 16. That's the question. Sorry, it is not 16, this is 116. 116. Some terms of this AP is equal to 116. Then for what value of n? I mean, for how many terms the sum becomes 16? That's the question. Yes. Here we have A 25. D, common difference is what? A2 minus A1, that is what? 22 minus 25, that is what? Minus 3. D is minus 3. So we have to find n. Sn is given. So for some number of terms, sum is 116. For what value of n? That's the question now. Okay. Now let me take Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay. Right. Now n by 2. So Sn is given 116 equal to n by 2. 2 into a is 25. 25 2s are 50 plus n minus 1 into d is minus 3. Let me simplify this. N by 2, 50 minus 3n plus 3. So 116 2s are, you get 232 is equal to n into, you get 53 minus 3n, or this is equal to 53n minus 3n square, or you get equation 3n square minus 53n plus 232 is equal to 0. Here we have a quadratic equation, right? 53n, so 2 into 232, sorry, 3 into 232. So you get 696. 696 is what? When you find the factors, I think minus 24 into 29. Right? Minus 24 into 29. You get 232, sorry, 696, right? 3 into 232. Right? Okay, now this can be written as 3n square minus 24n minus 29n plus 232 is equal to 0. Let me take 3n outside, 3n into, so n minus 3, so 8, so minus, if I take 29 outside, you get n minus 8, that is equal to 0, because 29n, so minus and minus plus 8, 29 8s are. Yes, so you get 3n minus 29 into n minus 8 equal to 0. So, this gives either n is equal to 8 or n is equal to 29 by 3, but it is not possible. So, not possible, n is equal to 29 by 3 is not possible because n must be some natural number because number of terms no. So, n is equal to 8. So, I mean when you add first 8 terms of this sequence you get the sum 116, that is it. Okay. Let me move to question number 7th one. Find the sum of n terms of the AP. Find the sum of n terms of the AP. M terms of the AP. Whose kth term is, whose kth term is 5k plus 1. So, we have to find sum of n terms of the AP. Kth term is given. Kth term in the sense it is also like nth term, right? I mean the nth term of a sequence gives any term of the sequence. It means it gives first term, second term, fourth term, fifth term, whatever. So, here we have kth term, right? You mean k is equal to 5k plus 1. This, by using this, let me find sum of n terms of the AP series. So, this is given. Right. So, now if ak is equal to 5k plus 1, then let me substitute in plus k1, you get first term a1 equal to 5 into 1 plus 1, you get 6. So, first term is 6, that is what a is equal to 6, a equal to 6, and a2 is 5 into 2 plus 1, in place of k I have taken 2, so 11. So, a2 is 11. So, these a2 minus a1 gives 11 minus 6, that is equal to 5. So, common difference is 5. Anyway, we have got a as well as d. So, now therefore, sum of first n terms is equal to what? Sn is equal to n by 2 into 2a plus n minus 1 into d. So, answer will be in terms of d one also, n only, because we do not know n. N by 2 into a is 6, 2 6 are 12 plus n minus 1 into d is 5, gives n by 2 into 12 plus 5 1 minus 5, that is, this gives n by 2 into 5n plus 7. This is a required answer. You mean if n is equal to 1, you get 1 by 2 into 5 plus 7. If n is equal to, you get, so this gives, in general it gives sum of any number of terms. So, in general Sn is equal to n by 2 into 5n plus 1. So, n is what? Number of terms. If it is 1, you get the first sum of, S1. If it is 2, sum of 2 terms. If it is 3, sum of 3 terms, and mean. That's it. This is what sum of n terms of sequence. Okay. Question number 8. If the sum of n terms of an AP, if the sum of n terms of sum of n terms of an AP is Pn plus Qn square, where P and Q are constants, find the common difference. Find the common difference. Yes. The sum of n terms of an AP is given, Pn plus Qn square for any constants P and Q. Then what is D? Yes, this can be found using the relation An minus An minus 1 is equal to D, right? Okay. So for that we need to find An. So An can be got by using the result Sn minus Sn minus 1 is equal to An. So anyway, Sn is given, right? So given Sn, sum of n terms of the series is given, terms of the AP is given, that is Pn plus Qn square. Then what is Sn minus 1? You mean I am replacing n by n minus 1, that's it. Why we need this Sn minus 1? To find An, that's it, by using the result. So P into, let me substitute n minus 1 plus Q into n minus 1 whole square. I just replace n by n minus 1. This gives Pn minus P plus Q into A minus B whole square, n square plus 1 minus 2n, n square Q into n square plus 1, you mean Q into 1, minus 2n minus 2qn. N square plus 1 minus 2n. So Q into n square, Qn square plus 1 into Q minus 2qn. Okay, now Sn minus 1 is equal to, Sn is what? Pn plus Qn square minus this one, Pn minus P plus Qn square plus Q minus 2qn. Okay, now Pn get cancelled, Qn square minus of Qn square get cancelled. So what is remained? P minus Q plus 2qn. Okay, this is what P minus Q plus 2qn. Okay, so An must be what? A plus n minus 1 to D, right? So now this is, so An so yes, this is what? Okay, anyway, this is D, right? Sorry, this is An. This is An. Okay, using that result Sn minus use An. Okay, An. Now let me find An minus 1. Now An minus 1 is equal to, so just let me replace n by n minus 1, that's it. So you get P minus Q plus 2Q into n minus 1, or you get P minus Q plus 2Qn minus 2Q. Okay, now D is equal to, therefore, D is equal to an minus 1 is equal to, what is an? P minus Q plus 2Qn minus P minus Q plus 2Qn minus 2Q. This is your an minus 1. P minus Q minus of minus plus Q, 2Qn minus 2Qn get cancelled, so minus of minus 2Q. So your D is 2Q. So common difference of that common difference of the given AP whose sum of n terms is Pn plus Qn square is 2Q for any constant Q. Okay. So as this is the part third of the chapter sequence in series, and let me continue in the next class. Thank you.